So it's a hard problem today. Given a data stream input of non-negative integers a1, a2, a to n, etc., summarize the numbers seen so far as a list of disjoint intervals. So here you're actually going to be making a data structure, the summary ranges class. It's going to have three functions, three required functions. The first one is just the initializer. The second one is going to be to add a new number to this structure. And then the third one is the one we care about. That's going to be to return a summary of the integers currently in the list as a list of disjoint intervals start to end. And it should be sorted by start of I. Okay, so that's a lot, so let's just go over an example. So here's the data stream in question. We'll just call it DS for now. And these are going to come in one by one. And you don't know when you're going to be asked to actually produce the intervals. So it's actually up to you whether or not you want to actually maintain them or whether or not you want to just produce it at the time that you're asked for it. So let's just say for the sake of this example that after every single integer that we're given, we're asked to produce the intervals. So after we're given 1, the intervals are just going to be 1, 1, right? Because there's no other number in the intervals. Then we're given 3. So because 3 doesn't overlap with 1, we're not going to be merging any intervals. Our return is just going to be our first interval 1, 1, and then our second interval 3, 3, because it's still disjoint. Okay, so then we're given 7, and the story is the same. It doesn't overlap with any of the intervals we already have, so now we just have 1, 1, 3, 3, and 7, 7. Okay. So then we're given 2, and now it's going to get a little interesting because 2 it doesn't overlap, but it is going to connect two of our intervals that exist. You can see we have an interval for 1, and then we have an interval for 3, and 2 is going to go between them. So it's going to connect those intervals. So what's going to happen after we insert 2 into our data structure, this 1, 1 and 1, 3 are going to merge to become 1, 3. And that's because 2 is going to get put between these integers, causing them to merge. And we're still going to have 7, 7, right? Okay, and then we're going to be given 6. And similar to before, 6 is not going to go between any intervals, but 6 is going to go right before our 7, 7 interval. That means that 6 is now going to get merged with 7. So the result is going to be 1, 3, and then it's going to be 6, 7. So a pretty easy problem to understand, but of course it's labeled as a Leetcode hard, so don't expect it to be that easy. So what would be a naive solution to this problem? Well, as we kind of said before, you have the choice about whether or not you want to maintain the list as the data stream is coming in, or if you just want to produce the list at the time that it's asked for. So the more naive brute force solution is going to be just that, produce the list as soon as it's asked for. So in this case, we're going to be given 1, right? So our list of numbers is just going to be 1, and then we're going to be asked, okay, produce the intervals. So how we could do this is we could maintain sort of a pointer to like a beginning and end pointer on the list, and we could move the end pointer until we get to a number that doesn't have a follow-up, right? So until we get to a number such that end plus 1 is not that number plus 1, right? So just to elucidate that, so we're going to be our array is just going to be 1. So then when it's asked to produce the intervals, we're just going to have 1, 1, right? And then we're going to have 3 inserted into the numbers. So then our numbers is going to be 1, 3. So again, what we'll do is we could have this pointer here and this pointer here, and then you might start seeing a problem, and we'll see it in a bit. So if we have our beginning and end pointer, well, we could move this end pointer and see, okay, 3 is not 1 plus 1. So that means that our first interval, and it looks like I lost the draw, so let's just fix that. so 3 is not just 1 plus 1, which means that our first interval has to be 1, 1. And then the other interval, and then we would move the start pointer to 3. We'd put the end pointer at 3, and we'd see 3 is the end. So then our second interval must be 3, 3. Okay. So same deal with the last one. And I'll just kind of skip through this because it's the same story. There's nothing new. We'd have our first interval being 1, 1, our second interval being 3, 3, and our third interval being 7, 7. Okay. So then we input a 2. And that's a problem because if we're going to be using this 2 pointer method, then this 2 can't be at the end. So in fact, what we're going to have to do after every single call to our list is sort the list. So basically we'll get a call, then we'll sort the list like this. And now we have 1, 2, 3, 7. So then we have our beginning and end pointer, and our end pointer will move to 2. We'll see that, okay, 2 is still valid. 2 comes right after 1. So then we'll move it to 3, and we'll see, okay, it's still valid. 3 comes after 2. And then we'll move it to 7, and we'll see, no, 7 does not come after 3, which means that 3 was the end of an interval. So then we'll insert the first interval 1, 3. And then this beginning pointer will move to 7, and we'll see that nothing comes after 7, so we just have 7, 7, right? And then we'll get to our next number in the data stream, which is going to be 6, and it will be the same thing. We'll insert it, but then we'll have to sort it, which means we'll have 1, 2, 3, 7, 6, 7. And then we'll have do the same thing once again. We'll do our 2 pointer method. We'll end up with a pointer getting to 6, noticing 6 doesn't come after 3, which means our first interval must be 1, 2, 3. So 1, 3. And then we'll move this start pointer to here. And we'll eventually move the end pointer to 7. We'll see that 7 is the end of the list, so then our second interval must be 6, 7. Okay, so what is the runtime of this brute force solution? Well, let's say that n is the number of numbers that's going to be inserted, and then m is the number of times that return intervals is going to be called. Well, every single time that we ask for all the intervals, that's going to be m, we're going to have to sort the entire list. So that's going to be n log n. And to be honest, that isn't quite bad. But as this is a Leetcode hard, it is going to be a bit more tricky to get the optimal solution. So now we want to think about what kind of problem does this look like? Well, remember how we said before we can either produce the list at the time that merge is asked for, or rather the intervals are asked for, or we can always maintain the intervals. Well, the truth is that there's not really an algorithm for this, but you can already tell that had we already had a sorted list of intervals, this would have been much faster because we had to call that sort every single time. So let's imagine that situation in our example where we had 1, 1, and we had 3, 3, and we had 7, 7, just like that, right? Well, if we were given 2, then we already know that 2 belongs right here. So if we already have our sorted list of intervals, and we had a way to quickly find where 2 is supposed to go, then we could do this much faster, right? So that should be obvious. That's just a binary search. And if you have, if you're working in a language that has, say, a tree set like Java, or just a regular set like C++, or a ordered container like Python, then you can do this automatically. We can already quickly find where this 2 is supposed to go. So in that case, all we really should be doing is creating this 2, 2, and then figuring out how exactly do we merge these. Well, what we would need to do is first, we'd have to choose one of these intervals is going to disappear, right? So what we could do algorithmically is first put 2, 2 right here. Then we can we can try and merge these two intervals, right? So we could say, we would see, okay, what is the beginning value supposed to be? Is it supposed to be 2 or is it supposed to be 3? Well, 2 is less than 3, so that means that this new interval would be 2. And then we would look at, okay, what is the ending interval supposed to be? Well, 3 is greater than 2, so what we would probably do is change this to 3. And then this is valid between these two. And then we would probably just do the same for 1, 1, and now 2, 3. Which is lower, 1, 1 or 2, 3? Well, 1 is less than 2. So then what we could do is we could say change this to 1, 3, and then we would just need to delete both of these intervals. And that's actually all you really have to do, is as long as you understand how to use your, if you're in Java, your tree set to find where this is supposed to go, and you know how to just use a set in C++, or you know how to use an order, I believe they're called ordered containers, then you're fine, right? So in fact, since it's a little tricky to use these sort of ordered sets with vectors, what we could actually do is, instead of like a set, we could use a map and have every beginning value mapped to the end value. So that way C++ is just going to automatically order them by beginning. So let's figure out how exactly we're going to implement this. Okay, so here's what our algorithm is going to look like. And I've given a few examples which illustrate most of the cases that we're going to have. I'll actually start with the last one because this is the trivial case. In the case of inserting 5 into an example like this, it's not going to interact with any of the existing intervals, which means all we really have to do is insert 5, 5. And remember, we're going to actually use a map to do this, which means that what this is actually going to look like in code is going to be map of 1 equals 2 and map of 7 equals 8. And the reason we're going to do that is so that C++ is automatically going to sort all of these intervals by their beginning value. And we can also insert in a faster time, which is going to be log of n. Because remember, all of these ordered sets are implemented as trees, as binary trees, or rather balanced binary trees, red-black trees. So that's the trivial case. All that's going to happen here is we'll notice that it doesn't interact with any of our existing intervals, and we'll just create a new interval, which will be map of 5 equals 5. So that's all we need to do in that example. I just wanted to get that one out of the way. So then let's look at our first example. We only have one interval, 2 and 5, and we need to insert 1. So our algorithm is going to be, first, find upper bound. That's the first interval that is greater than the value that we have. In that case, we have 2. So in code, map of 2 is going to equal 5. So when we ask C++ for the upper bound, it's going to give us this entry. Find the lower bound. Well, the lower bound is smaller than the size of the map, which means that there is not going to be a lower bound. And since there is no lower bound, the lower bound can't overlap. So does the lower need to extend forward? No, it doesn't, because there is no lower bound. And does the upper need to extend backwards? Yes, because 1 is exactly 1 less than 2 and 5, which means what we're going to do is we're going to insert into our map this. 1 will equal 5. That's how we're going to insert, which means that's automatically going to get sorted. Then, as we said, does upper bound need to extend backwards? Yes. If so, apply the new interval and then delete upper, just like that. So then let's look at the second case. We need to insert 5, which is greater than any of the values that exist. So when we try to insert 5, we'll find that there's no upper bound. And then we'll go to 2, and we'll see get the lower bound. Okay, the lower bound is 1, 4. Does the lower bound overlap? So is 4 greater than 5? No, it's not. Does the lower bound need to extend? Yes, it does. So all we actually have to do here is we don't even need to insert anything. All we need to do is change map of 1 to equal 5, just like that. And then the rest doesn't matter. We've already solved it. So now comes 3, which is the less trivial case. As you can see, 3 is going to need to go between 1 and 2 and 4 and 5. So first, find the upper bound. This one. Get the lower bound, which will just be 1 less than the upper bound, just like that. Does the lower bound overlap? No, it doesn't. Does the lower bound need to extend? Yes, it does. So we'll go ahead and extend it. So then map of 1, which previously equals 2, is now going to equal 3. Does the upper bound need to extend backwards? Yes, it does. Map of 1 will not equal 3, but then we're just going to change it to 5. And then, if so, apply to the new interval. So we we set map of 1 to equal 5, and then we delete this. So now all we're actually left with is this. This was changed to 1 to 5. And then after that, when we're asked to actually return the intervals, it's pretty easy. All we do is run through all the entries in the map, and we just return an interval of their key and then their value and so on, just like that. Okay, so that was a lot, but let's go to code. Forgot what's going to be the runtime of this. Well, compared to the brute force solution, it's quite fast. Since we're implementing this as a tree map, it's actually only going to be log of n in order to insert, and then it's just going to be n in order to produce the intervals. So pretty fast. So the first thing we're going to actually need to do is create that map, because obviously that's how we actually store the intervals. So we'll just call it intervals, just like that. Easy. Okay. So the constructor doesn't really need to do anything. We don't really need to do anything in the constructor. Before we actually go on to add num, let's go ahead and just finish up get intervals to make it easier on us. So we need a vector of int vectors as our return, right? Then what we need to do is we need to go through all of our maps to get our intervals. So for auto, or rather, let's do const auto, because that's going to make sure they're done by reference. It'll be a little faster, right? Then all we actually have to do is dot push back a vector of size 2. So that's just going to be p dot first, and it's going to be p dot second. So that's the beginning of the interval, and that's the end of the interval. And then all we have to do is return ret. Okay, so that was the easy part. So let's go ahead and do the hard part. So what we're going to need is a value to keep track of what the beginning of the interval is going to be and what the end of the interval is going to be. So let's just make that int left, and we'll start that as equal to the value, and int right equals the value, just like that. Okay, the first thing we're going to need is the upper bound, the first interval above what we're actually going to insert. So let's just call that UB. And that's going to be, I'd love to just say upper bound, but that's already a function, so we can't quite do that, or rather we shouldn't do that. And that's just going to be intervals upper bound of value. So if you've never worked with ordered sets in or ordered maps in C++, the upper bound function, in fact, this will work in any sorted set, will return you the first value, an iterator to the first value greater than what you've asked for. And if it's not in there, it's going to return the iterator after the last entry. So first we need to, what we need to do is figure out if this is even in the set, right? So if the value we need to insert is smaller than everything else in the array or everything else in our intervals, then what's going to happen is the upper bound is just going to equal the first value, which is intervals.begin. So in the case where it's not, if it's not the case that upper bound is before all, if this value is before everything else already in there, well, we need to deal with that. So the first thing we need to do is get the lower bound, and the lower bound is just the next smallest. So we'll call that lower bound, and how we'll do that is we'll just do equal to upper bound, and then we'll just do that upper bound minus. So that will give us the first interval before what we need to insert. If that lower bound, if the second part of the interval, if the second entry in the interval of that lower bound is greater than the value we need to insert, what does that mean? Well, that means that it's already in there, right? So if we have 1 and 3, if the lower bound is 1, 3, and we're trying to insert 2, then that means that 3 is going to be greater than 2, and it's already in there. We don't have to insert anything. So if it's greater than or equal to the value, well, then we can just, in fact, save space. We can just return. We're done. We're good to go. So what if we need to extend lower bound? Well, that's the case when the lower bound second is exactly value plus or value minus 1, right? That's when we need to, the value is exactly 1 greater than the interval that it comes right afterwards. In that case, we're going to go ahead and set our left value. Left is going to equal the lower bound first. So the first part of that interval. Okay, so that takes care of that situation. Now we need to consider the upper bound. So we've considered all of the lower bound stuff. Now let's consider the upper bound. So if the upper bound does not equal intervals.end, well, what does that mean? Well, that means that it's the upper bound is already in the intervals. So this new value is not going to be at the end. Sorry, it's intervals.end. But it also needs to be the case that upper bound, the first value, if we need to go ahead and extend this upper bound value, if that's exactly equal to our value plus 1, so that means that the interval that comes right after our new value is exactly 1 greater than our value, well, that means we need to extend it backwards, right? Or rather, we need to do our right is equal to the upper bound second, right? So that means that now we know what our right value is. Well, our right value is going to be the end of that value. Well, now we can just go ahead and erase that old upper bound value. Just like that. Okay. So we have our left and we have our right. So what do? All we have to do is, because we made it a map, the intervals of our left value equals our right value. That's all we have to do. And I believe that should do it. I guess I'll go ahead and stake my reputation on a submit. And sometimes it doesn't quite work. Okay, so I actually had to log in, but we got accepted, almost greater than 100% of submissions, and that was data stream as disjoint intervals.